All right, welcome back. In this chapter, chapter number 8, we're going to be looking at statistical functions. So we'll be carrying on learning more advanced functions and features. This is not going to be a statistical class, but we're going to be showing you how to use statistical functions in Excel. You'll still have to learn how each of these functions work and what the numbers mean. We're not going to talk about the meaning, but we're going to talk about how to develop and get the answers that we want. All right, so today's class, you're also going to need to have a working file. You can get this file from the Blackboard site. If you go into the course outline, which is the first link in the Blackboard site on my course, which you've probably all been there, and you look for the link here called My IT Student Lab Files. When you click on that, you'll be prompted with this site here, Student Files, and you can go down to Statistical Functions and download the file that you need for this class and to follow along. All right, so the other learning objectives we're going to do is not just looking at statistical, but also accumulative functions, aggregate functions that have conditions in them. So these are conditional, I guess, statistical functions as well. Things if you have a condition that you want to sum up, if there's a condition, a single, or if you have multiple conditions or criteria that you want. We'll also look at some statistical functions such as rank, percentile, quartile, percentile, those types of things, and frequency as well, and looking at correlation and looking at an analysis pack. So we got lots to cover in this chapter, lots of good things to be studying. So to get started here, what I'm going to do is I'm going to open up the example that the book gives you. Now I've got a lot of the data in here already, so I'll be just reviewing this with you guys. Now, first of all, it's always important to understand what you're looking at. So over here on yours, you'll be getting those 4 columns right there. And this is data that is dealing with teachers that were hired on a certain date that make a certain salary that work in a particular town. So questions that we want to know from the data is, one question we can get is, how did the individual rank amongst all their colleagues? All of the different faculty or staff, and how did they rank? Now, ranking could be easily calculated by just looking at the salary and sorting the salary. So what I've gone ahead and done is I've actually taken out the table and I just went into the data. I click on filter and I added the little filter controls and simply just said, well, okay, if we want to know how they rank, we could do the largest to the smallest, or the smallest to the largest, and rank everybody. Now, we're missing number 1 here, and that's because there is probably an error somewhere in the system, and it's always good to check this kind of stuff. So what I'm going to do here is I'll take out the ranking data right here, and let's type it in again to see how this works. Now, I could just sort this and rank it according to, this is the lowest ranked to the highest ranked, but if the salaries change, then the rankings will change and then they will no longer be valid. So if data is going to change or is dynamic, we need to use a function rather than a static value. So let's take a look at the rank function. Now, as soon as I type in rank, you'll notice that the Excel pops up with all the options for rank, and there's actually 3 of them. This first one here is just called rank, and you can still use it, but they have like a little cautionary symbol here. And basically, they're saying that because it's a legacy function. This is a function that was used in the older versions, and every time you see this, it'll say that it was done in an older version. And what they've done is they've gone ahead and they've modified the rank, and they've made subtle changes. So, for example, you can rank based on the regular ranking of what the numbers equate to, or you can do a ranking about what the relative average of how they rank. So there's slightly very different variations to the function. So what they do is they have a function, and then they have a dot, and then they have a sub set here of that function. All right, so if I just use rank and equal, I believe these 2 are the same option, but I'm going to start off with the EQ one here. So I'm going to go equal to EQ. Now, of course, just like any function, it pops up with the arguments. So it says, well, what number am I looking for? I'm going to rank this first person, this Park person, and I want to rank their salary. So I click on their salary, and that salary is relative to this ranking. So I don't want to make any changes to that. So I'm done with what number I want. I put in a comma to go to the second argument. You see the ref, which is what reference. What are we referencing? Where's the array or the range that we're referencing? And this argument doesn't really explain that in that much detail, which is unfortunate. Although we could go up in here and click on fx, and it would give us a little bit more instruction. It says as an array of, there we go, right there. So it does give a little more definition or explanation. So I want to go in here to reference, and I want to reference all of these. So I'm going to go down here, and I'm going to push, there we go. And it says here there's a total of 50, and you'll notice here when I do that, the wizard function dialog box here comes up and it shows you in these braces, which is an array of values, and that's just these values right here, the salary values. Now if I push enter, I come up with they're the 50th ranked, and that makes sense because I sorted this in descending order, so they would be the lowest ranked of the 50 people, so they would be 50. But the problem is if I copy this down from here to here, let's go all the way down to the bottom, and let's see how that goes. You can see what happens is the range is starting to be relative to. It's moving down as I copy. Like look at this one down here. I move it down here and it copies. So it really throws stuff off. So what I want to do is I want the number, the blue one here, to be relative, but I want the range to be absolute. So I'm going to push the F4 key. And when I do that, it locks in the entire cell and the entire range as column and row. But I want to push F4 one more time just to lock in the rows, because I'm copying down, so I want to lock the rows in and not the number. So this is probably the most correct way of doing it, even though the other way would work perfectly fine by using a full locked in range like this one here. But if you really want it to be more accurate, it would be this one right there. And that's a mixed reference. Now when I push enter, now this should work a little bit better, and we don't have any issues with that, and it sorts everything in the correct order. So it's ranked it. Now, the nice part is if I change the 50, let's say this person got a really big raise to $70,000, you should assume that they're going to be ranked number 1. And sure enough, they are. So they become ranked number 1. If I was to put in the static data here and just manually type in what the ranking was based on their sort, it would be static and it wouldn't change. So for example, if I was to go back in here, and I'm just going to put this back to 31,000, and I say, okay, this is the lowest ranked person, and then there's 59, and then let's just do what we could do, a little formula. Oops, do a little formula here, this minus 1, and just copy down. All right, so if I change this to 70,000, of course, the ranking doesn't change because it's just a static number. All right, so that's why we use the function called rank. And the other option was to rank with average, but we're not going to do that one right now. I just wanted to show you how the rank function worked. All right, let's move on to the next feature here, which is the more advanced aggregate calculations with a condition. Now the condition is to answer questions. So I've written out some questions here that the computer wants us to answer. They first of all have this area right here where they want to count up some summary information of everybody that was working before a particular date. So the question I want to answer first is, how many educators were hired before January 1st of 2015, or before the year 2005? So there's 16. Now, how did I come across that? Well, let's go through and work out the calculation. So the calculation is an aggregate with a condition. So it's equal to count. And if you look again here, there's a lot of counts. There's 1, 2, 3, 4, 5, 6, 7, 8 different functions that allow you to count. Now, count on its own, we've done that. That just counts a number of values. Count A means count not only values, but labels. It counts everything, or A stands for all, so count all. Count blank spaces if you want to find out who's missing the data. But the one we're going to look at right now is count if. And it counts the number of cells within a range that meets a given or a single condition, one condition. If I was using if-SA, it would allow for multiple or a set of conditions or multiple conditions. I only have one. My condition here is, how many people were hired before 2005? So now I got to answer the question by entering in my arguments. The first argument is what range. So my range is, what do I want to do here? I want to count how many people were hired before 2005. Well, that's the date. So my range of dates, I have to look at all the dates. That's the range of dates. And that's all I need to do. And I don't have to make it absolute because I'm not copying this down. It's only for this one, so it is what it is right here. You don't have to make it absolute. It can be relative. Now, if I put in a comma, let's go to the second argument, which is the criteria. And the criteria is the date. But I need to put in some kind of logical descriptor to explain that it's less than the date. If I was to just type in the date, it would say, well, it's going to be equal to, but I want to be less than that particular date. So I have to use a less than symbol. And now this is how the syntax works. You have to put in a quote, literally put in a less than symbol. But I also want to put in the date. So what I use is an and sign, which means add or as well as or and the date. And the date is located right here. Now I've changed this slightly different than yours, and I would encourage you to do this as well. And what that does is it's going to look through each of these ranges for anything that's greater than this date. Now I set it up like this in case I wanted to change my date. Maybe I wanted to type in 2007, and I can see right away I can play what if. Well, there's 24 people. 24 people were hired before 2007. All right, so if I go back and I change that back to 2005, it changes dynamically. So what if we go back to 2005? Well, that would be 16 people. So we've answered the question. The question was how many educators were hired before 2005, and the answer is 16. Now another question might come up is what total salary of those educators? How much did we pay those teachers? So to do that, we got to come up with the function. Well, the function is an aggregate function, which is to total up the payroll. So we're going to say equal to the sum of, and I'm going to say sum with one condition, which is if, and I can hit the tab key or I can click on it, either of those work. And I got to type in the range, criteria, and sum range. Now let's deal with the range and the criteria. The criteria to the question is, I want to look at the dates, all the dates again, so I can type all these dates. I could have named that range, by the way. And then comma, the criteria for that, again, is going to be equal to greater than, or I'm sorry, less than, and I also want the date in there. All right, so that's just like the count, but counting is simple. It just counts them up. But in this case, I want to sum up. But what do I want to sum up? I want to sum up the range. Sum the range of what? What am I trying to sum up? I'm summing their salaries. I want to know the total payroll. So I'm going to highlight all of the salaries and push enter. And sure enough, I get $809,754 for those 16 people. Now, if I change this to, let's say, 6, I could say, well, how much is the salary for that? Well, there's 19 people, and it's $943,153. Perfect. All right, let's do one more of these, and that is the average. All right, so let's go into average, and it's the same thing. You should see that this is starting to become a little easier. Average if, and the range, again, would be the same. I'm going to average. The question is still the same. It's how many people, what's the average based on people who were hired before 2005. And I'm going to go comma, and I'm going to go less than, and I'm going to, and I also want the date here, and I'm going to comma average what range? Well, I'm going to average the same. So virtually it's the same as the sum, and I'm just basically repeating it. So I've got 6 people that work, oops, so not that one. Sorry, I got 16 people that averaged $50,609.63. That's the average salary of those people. And I can go in here and change the date, and all this data right here will dynamically change for me. All right, let's move on to another example, or more complicated example, which would be 2 conditions. In this example, I've got a township that someone works in, and I have a date. So I've got 1, and I got 2 criteria. So the question is, how many educators were hired before 2005, and big part there, and live in Acorn, the town of Acorn. All right, so to get started with, let's type in the function. It's an aggregate calculation of count, but this time we want a condition, but not just a single condition. We want a multiple condition. So I'm going to click on that one, and I'm going to type in the criteria range. Again, I want everybody in this particular date range to have a criteria that is less than this date. That's the first criteria. Now I've got a second criteria. Both of them have to be true. The word and is a logical comparison operator. That means that both have to be true. I want this and I want that to be true. So the other one is they have to live in Acorn. So the field for Acorn is, or the criteria range is all the cities, or the townships, they call it. And I'm going to go comma, and I want to type in, what's the town? Well, the town's right here, it's Acorn. I could have just typed in, Acorn as a literal constant, like this, and it would work. But that would make it static, and I don't want to make it static if I can help it. I'm going to say I've already got Acorn typed out. I can change it to Acorn here, and sure enough, that appears. Similarly, if I was to change Acorn to Jackson, it would change all of this, and now I've got 4 people that work in Jackson that were hired before 2005. Perfect. All right, let's put that back to Acorn and 2005. Now, total payroll is virtually the same thing with the addition of one extra argument. Let's do that. Total payroll, aggregate calculation of sum ifs, bracket. What do I trying to sum up? Well, I need my ranges. Sum up the range. Now, the other one was just the criteria range. I need the sum range. Sum what? What am I trying to sum up? I'm trying to sum up all of the salaries. So you've got to pay attention to the arguments very, very closely. All right, comma. The next one is, what's the criteria range? Is the dates. I'm going to highlight all the dates. There we go. And I'm going to go now into the criteria of the dates, which would be less than, again, of the end of before 2005. Okay, so that's the first criteria I want, comma. You'll see here, what's the second criteria? Well, the second criteria is if they're in the township of Acorn. So I've got to first of all type in my criteria range. What am I looking into? So that's the range of all those. And again, my criteria, I'm looking for Acorn, which I'm going to put in as just the individual cell location here. And I'm done. Push enter, and it says here that those 6 people that work in Acorn that were hired before that date, total salary is $308,419. Now, average would be very, very similar to this, as you can see. So what I've noticed some students do, if you click on this formula and this formula, they're virtually the same in so many aspects, except the word sum goes to average, right? So if I was to grab this and copy down, and then simply just change this word sum to average, you think it might work, but it doesn't. And then, so you have to delve a little deeper into that. This is because when I copied it down, everything copied down relatively. So that meant that this red range dropped down 1. So I can pick it up and drag it. The blue one did, so I can fix it if I want. I'm showing this as a demonstration of how you can actually edit and manipulate functions in this way. So I basically didn't have to go back through the logic of the arguments because we've already covered that twice. I'm showing you another way of doing this. And there we go. The average salary looks correct. All right. Perfect. Now, let's have a look at the next learning objective, which is talking about the quartile. Now, quartile is just looking at, is a statistical, won't get into it in a lot of detail, but what we want to do is we want to group together everybody here into 4 sections, basically. Everything that the lowest quartile would be less than 25%. The second quartile would be 25 to 50%, and then, or 49%. And then the third quartile would be 50 to 75, and then 75 to 100. Now they name these 0, 1, 2, 3 because computers like to start everything at 0. So it's not like the first quarter, second, third, and fourth quarter. That's just how they do it. All right, now to do quartile, again, you've got this function with this additional feature they call inc or inclusive. All right, so how does it work? All right, so let's have a look at this. I'm going to take these out, and I'm going to do a quartile as inclusive to start with. So equal to the quartile You'll see here when I type in quartile, there's the old one, which was basically was inclusive. Then they came up with one which is exclusive, meaning that they're taking away the extremes of those. All right, so it's a subtle variation to the statistical value of what is a quartile. And I'm going to do the inclusive on this one. So I'm going to go inclusive, and it's asking for the array. And again, if you're not sure what the array is, we can go back up in here and it would come up and give us a little more explanation about what the array is. An array is like a reference range. Array is sometimes referred to as a range. So these terms are used interchangeably, and it's unfortunate that Excel isn't more consistent with their naming conventions. There are slight subtle difference variations, and it goes to a programming concept as well. All right, let's go back in here and type in quartile inclusive and my ranges. So what am I trying to do for my quartile? My array is all of my salaries. So I'm going to go down here and pick all my salaries, and I want to find out what salary is in the first quartile. So you see here, the first quartile is in the 25th percentile. The second one would be in the 50th quartile, 70th, and then the maximum. So it kind of gives you an example of how this works, where if we include it, we include all 4, or 0, 1, 2, 3. And if we exclude it, we're only getting 1, 2, 3. So I'm going to stick with my quartile, and I've got the quartile over here. So I'm going to go 0. And that one's relative. This one's absolute, so I got to make sure that I lock it in. So I'm going to hit F4 once. That's for the entire range, but I don't need to lock in the column and the row. I can just lock in the row itself. All right, and then from there I can hit enter, or I can close the bracket, and it comes up with the number. Perfect. All right, so now if I copy that down, I can double click the bottom right handle, and you'll see here how it copies it down, and it's found the largest salary in the range. The lowest salary within that range, that quartile range. And similar to the second one, this is the lowest salary within that quartile, etc. All right, let's have a look at a similar concept using what they call the exclusive. You're excluding that other quartile, the top quartile. So you're only doing the 1, 2, and 3 here. It's virtually the same thing, except we're using the extension here of ext to exclude, and we're putting in the range. We're going to lock it in. As you can see, I've locked it in here with the row as the mixed reference, and G17, which is the quartile that we want for this particular one, and it breaks it down, and it gives you a slightly different statistical analysis to this. All right, now if you were looking at the textbook, all right, there's the textbook talking about the quartile, the percentile. It's basically, it's explaining the same thing, and this is the table that might explain it a little bit further. That what the quartile 0 is, and it's only available if you use the INC to include the 0, where exclude is to exclude the 0. This is the first quartile's latest is the 25th percentile. This would be the 50th percentile, the 75th percentile, and the maximum as well. All right, so if you need more information about how the quartile works, your textbook, table 8-1 should give you some more instructions on that one right there. All right. All right, we're going to carry on to the test scores, and we're going to look at some other aggregate type of calculations. Just as a reminder, if you were going to calculate the maximum test score. So let's first of all, again, look at the data. We're looking at a bunch of students' grades. This is maybe their SATs in the US and what scores that they got. So this is a student number. This is their score, what town they're from, the school district number, and how many days that student was absent from school. So this is the data that we have to work with, and we want to do some statistical calculations. So start off with, we've got some very, very basic stuff here. What's the maximum test score? So how are we going to calculate maximum test score? They've got down 800 already here, and if I scroll down through the list, I could probably see, is there anything larger than 800? There's 800, no. So it looks like 800 is the answer. I could just go back up into data, filter, and click on test score and say the largest, and said, yes, 800 is correct. The sample size is how many there are. Well, I could do that too by just selecting one field of all the data in all those records, and down at the bottom it says the count is 50. I could do the count here to get that, and it's probably a good way to go, because if you want proper and accurate data over time, you'll want to have functions rather than doing it manually. And if data changes, of course, then the sample size would change. Average, of course, would be simply just averaging the data of all of the scores. So some basic statistical options. Now we have more advanced statistical options, and there are many in Excel. In fact, if you guys go up into formulas, you can click on more functions, you can click on statistical functions, and you can see here that there are several statistical functions that come as a default in Microsoft Excel. Now there are many more than this if you want to get into it, but you may have to add the analysis pack, which we'll do later in this lecture right here. So we've done minimum, we've done maximum. Which other ones have we done? We haven't done a lot of statistical ones, but we're gonna do the if count, if counts, and a few other ones. But the one we want to do right now is standard deviation. Now, if you don't know if you can even have a standard deviation in Excel, one way to do this is you go into here under functions and just type in standard, space deviation, and you could do a search for it. That'll give you every function that has the word standard in it. And you could go through here and find out where is standard deviation. And you can see here there's lots of them. All right. So maybe I want to be a little more specific. I'm going to actually go into deviation, and then I'm going to say go. And okay, all of these still have to do with standard deviation. But the one I want is STDEV, or with the P or the S. Now, if I go back in here, another way I could do this is just by typing in STD. As you become more familiar with these functions, you'll get to know what they start with. So STD, and then it tells you the P is the entire population. So you want to do a standard deviation with the entire data set, or do you want to do ignoring the extremes, deviation based on a sample, ignoring logical values and text in the sample. So slightly different variations. And again, we have standard deviation, which is the S, and then we have standard deviation with the population. So those two right there were retired functions that were replaced with these two here. So there's the standard deviation that basically ignores the outliers, and we could do it with the S is perfectly fine for now. So we'll see what the two different values are. What's the standard deviation with all of these test scores? So I'm going to go through and select all the test scores. What's the numbers? And I'm going to select OK. So it comes up as 181. Now let's do, that was using the S or standard. Let's do the one with the population, equal to the standard deviation with the entire population of the same data right here. And the answer comes back as slightly different. You can see that they give different results because one includes everything and one doesn't. All right. Variance is a very similar concept in the way that the functions are entered, but gives you, of course, a statistically different value. So the variance, again, I could just type in VAR and hope I get lucky and find it, or I could do a search through this one here. And again, we've got the similar type of thing. We have variance standard, or we have variance with the population. We have variance dot standard or variance dot population. So I'll do the standard one to start with here. And we're going to do a variance on the test scores. So go down to the bottom and press enter. And we can see we got the variance number here. And what that means is statistical value based on the numbers. And it would be more of a statistical learning objective. And it's beyond the scope of this class to go and explain what statistical information is. If you're interested, you can take a stats course. You can do a video on variance to figure that out. This is with the S, and now I'm going to try it with the entire population, so equal to the variance of the population. And I'm going to select all of them again. And let's see what we come up with. Is there a variation? And there's a slight variation because one includes the standard or everything or the entire population, and one is it excludes that. All right, let's do correlation. Equal to, you can probably see the pattern here. Now correlation is just correlation, returns the correlation coefficient between two data sets. Is there a correlation? Now, what does that mean? Is there a correlation? Well, first of all, we have to maybe understand what the data is to do a correlation. So we have to correlate, and the question might be, that's pretty obvious here, is the test score higher, or is there a correlation between test scores and days absent? All right, so which is kind of interesting. And if we look at the data here, this person down here has got 275, but they missed 10 days. This person up here got 789 and missed still 9 days. So there's still people that missed a lot of days but did well. But is there a correlation between the two? So let's do that. Correlation is coral. And what's the first array? I want to check out all of this. Is there a correlation, and what that correlation statistically is between, and I'm going to hit a comma, and I'm going to go to the second array. And the second array is right here, the days absent. Is there a correlation? Now that's going to equate down to a number, and that number is a statistical number that shows whether or not how much significant correlation is between those two different data ranges. So that interpretation is really, up to you to interpret statistically. All right, now let's move on to the next feature. This is called frequency. Now, frequency is very interesting because what this does is it allows you to check to see how many, let me take that out here for a second, how many people were absent, in this case, for any particular, how frequent. So how many people were absent one day? So I could go, okay, or 0 days. So these people didn't miss any classes. 1, 2, 3, what do we got? 4, 5, 6, 7. Okay, so there's 7 people that didn't miss one single day. Now I could put a 7 here and then go down here. And how many people did 1? Okay, there's 1 and so on. 2, 3. And I might even make mistakes here. So that's very dangerous. So there's a statistical way of doing this using a thing called frequency. How frequent does these data come up for this particular area? This is what they refer to as a bin. Let me just explain that. This is like a bin. It's like a container that's I'm going to stick 7 into. This container I'm going to stick 3 into. This container I'm going to stick in something else. And I want to know how frequent that people are missing classes. So I'm going to use a function here called the frequency. And the frequency, I have to type in what is the data. Well, the data array, again, is like all the data, or the references, or the range of all that right there. Okay, and I'm going to go comma. And what is the bin array? Well, the bin array is right over here. And I'm going to highlight all that and press enter. And sure enough, I do have 7 people that never missed a day. I have 3 people that missed 1 day. I have 7 people that missed 2 days, and so on. So it's a very, very handy little feature to show how people are, number of days people are missing. Just another statistical calculation to calculate frequency. All right, now the textbook, now this one worked quite well because the new version of Excel automatically does this. Now, it's not as easy, I think in the book, we'll show you that you need to use a slightly different method. Because this is an array function, a function that's going to be carried on through the entire data set here, you should actually follow this method. You highlight all of the corresponding bins that you want to count plus 1, and then you type in the function of equal to the frequency, and we'll go frequency. You want to type in your array as normal number of days. Okay, so that's fine. It's right here. Good. And then you want to type in your bin. Now, I'm only going to type in the bin. Close the bracket, and then to enter it, you have to go Control, Shift, and Enter. That is so bizarre, but you go Control, Shift, Enter is how you get it in. So just to make sure, it's the Control plus the Shift plus the Enter key that you need to press to lock it in. And I'm pretty sure that's how the system works when you've got, when you're doing the test, when you're doing the simulation. So you may want to practice that. This is in the textbook. I can show you right here. All right, in the textbook, chapter 8, using the frequency function, if you, as you go through it, it will explain how to create that frequency based on a bin. And what's important is to make sure that your bin has either a whole value or a range. And the other thing is, when you're entering the frequency, that you must enter in the control, shift, and the enter key. So very important to get that in. All right, let's move back on to the next feature here, which is your high school samples. And oh, is that the next one here? Did I get that right, or have I missed one? I think I missed one here somewhere. All right, let's move on to the next topic, which is looking at the data analysis tool pack that comes with Excel. Now, this is a tool pack that's not installed in Excel by default, and if you have a Mac computer, this might be slightly different than if you have a PC computer. So I know some students have been struggling with their Mac computers and not having the same thing, because there's virtually two separate versions of Excel, one for Mac and one for PC. So that's why some of the discrepancies. Now, in this next data set to do some calculations, what you're looking at here is samples of high school SAT scores for 3 separate high schools. So they haven't identified the student, they just identified the scores. Now, this might be done because some school districts are actually incentivized to get students to get higher marks by teaching them to be smarter and giving them more money so that they can spend on different programs in their school. So they might have to do some analysis on this. Now, we could do some basic aggregate stuff, which would be something like, you know, what is the average, for example? What's the average, you know, one right here. So I could go average. Let's go here. What's the average score for the first school? And there we go. And then could I just copy this across? It works. So I could go, let's say those 3 right here. I could say those are the 3 there. Select all 3, double click it, and we've now got the averages. So we can see here that school number 3 right away is averaging higher than the other 2 schools. Very simple calculation. That would be the average. Now we could calculate the total. Now that's kind of an odd calculation, but we could say equal to the sum of all of this data right here. And what we're trying to do is just trying to analyze what the data we have with the functions we have. Now, when I copy it across, because I'm going from school 1 to school 2, it's going to be relative, that data, as I copy from here. That's for school 1. When I move over to here, it's relative, so it moves it over relatively. So if I move this one over, it should work. And there we go. So now we could graph those. We could take those, you know, the titles and the totals, and insert and do a graph, and very clearly see that high school 3 looks like it's outperforming the other 2 high schools. Well, that's one way of rapidly doing that. Let's just remove that for a moment, and let's look at this in a little deeper method using the analytical tools. Now, what we want to do is add what they call a tool pack, and the tool pack, as the textbook explains, is loading the tool pack. You have to add in through the add-ins. And there's one here called the analysis tool pack. We did the solver add-in, so this is basically a review. So let's go back in here and do that. Now, there's 2 ways we can do it. One is under the developer tab by clicking Excel add-ins and selecting the analysis tool pack. So I'll click that. I already had it on, but I'll turn it on. The other option is to go into File, go down to More, go into Options, go into Add-in, go into Excel add-ins, go, and basically we get the same list as we did before. And that's the other way to do it. So we know we've got it, but where did it go? Well, the analysis tool pack resides in the data tab. So you go in the data tab, a new group is called analysis, and there is the data analysis. Just like if we had the solver installed, you'd see solver would pop up right there. So I want to go into the data analysis tool pack, and what this does is it has so many predefined statistical calculations and tools that you can do, from what they call an ANOVA single factor, which we'll look at it here in a second, correlation or covariance, histogram, which we'll do, calculating random number generators, rank and percentile, which is kind of neat, regressions, and then if you're doing some kind of quantitative analysis on, maybe you're doing some research and you want to do some t-tests. So these are all sort of advanced, a little more advanced statistical tools that come with Excel, but they're not loaded by default because not many people use this. All right, so let's take a look at the very first one. I'm going to go back in and say, let's have a look at a ANOVA single factor analysis of this data. So what can we do? Well, what we can do is we can say, let's set up and get the computer to do what they refer to as an ANOVA single factor analysis. The input range would be all the data, including schools 1, 2, and 3, including their titles, in a column format. So these are in columns, yep, they're not rows. And the top row here has a label. I'm going to leave that on. The alpha variable can be left as default. And where do we want to put it? I'm going to say the output range, I'm going to stick it over here under F2, not F22, F2, and say OK. Now, look what the computer did. Now I'm going to just expand this a little bit so we can see it. And what it does is the ANOVA factor goes out and looks at that highlighted range, and it groups together the labels at the top that I said, high school 1, high school 2, high school 3, and it does a basic aggregate type of statistics. First of all, the summary, how many data points is there in each column? 50. What is the sum? There's the sums, which is kind of what we did before. So similar to if I was to grab this and this data, I could simply click on, a recommended chart, and you can see again, school number 3 is definitely where it's at. The average is school number 3 too, and the variance has a tighter variance with school number 3 as well. So right away, you're starting to see that. Now, in addition, the ANOVA single factor also has different types of calculations between groups. Now, I'm going to make a disclaimer here that this is not a statistical course. I am just showing you how these tools work. If you want to learn more about what SS means, or DF, or MS, or F, or p-value, or so on, you're going to need to take a statistical course or watch some videos on each of these to learn how that works. What I wanted to show in this example here is how we can add the analysis pack to Excel and how we can use it to analyze a large consistent block of correlated data right here. All right, I hope that makes sense when it comes to adding the data pack, and that's under data right here. And there is again, if I wanted to, I could say, let's go in and add the solver. You guys remember that one? And I'm going to go back into my data. Let's see if did it work? Yeah, there it is. There's the solver. You guys will probably recognize this one right here, as that was in an earlier chapter. Now, if you also look at mine, I've actually got a lot of extra ones in here. I've written some of these myself. You won't have these, and some of them are customized. These are custom programs that we've written for work at Douglas College. These are my grade functions to help me with marking and analyzing student grades. This was an example for a loan calculator, which I think we've talked about in previous chapters, but this is actually writing a computer program to do it, and other ones that I've also written, my personal macros and functions that I've written as well. But this is just an example of how you can get. And by the way, you can also download some of these. There's there's an incredible area, or almost like a whole world of Office add-ins that you can get. Now, for some reason, I've tried this and the store is not available right now. I'm not sure why, if it has to do with the new version. But it's like an app store for Excel with all sorts of different types of calculations. Whatever discipline that you guys are working in, there could be different apps to help support that. All right, let's move on to the next one right here, the combination of score. Now, this one right here is looking at, again, another analysis version called the histogram. So what I'm going to do with this one here is I'm going to, first of all, remove it, because it's already been done, so I'm going to delete that out. And yes, I'm going to take out the chart. There we go. And what I'm going to do is I'm going to do this again using a bin. And you guys might remember the frequency for the bin would be equal to the frequency and the data of the frequency of the absences of the students had or that were recorded. All right, and then let's go back up the top, comma, the bin array, which is right here, and I'm pushing enter, and it should break down. And if I add these up, it is 150 records. So if you look at all of these, is there 150 records? Let's just double check. And it's 150. Good. So I do this a lot. Whenever I do something like a calculation, I don't necessarily trust it right off the bat. I want to do a little bit of backtracking. So I just want to make sure that the number of absences of 0 to 4 is 12, and then 57, and then 81. It's just how the frequency works out. Anyway, that might ring a bell for the frequency. Now, in this example, I want to use the data analysis tool box, and this time we're going to do a histogram. So let's do a histogram, and we're going to go into OK, and let's have a look at the histogram here. The input range I've got set as all of the absences, just like we did before, and I also include the labels of the input range and the bin. You see the label at the top called bin, so I'm going to make sure I've included that, and I've got the word label selected. I also want to output my results from this analysis to H3. I'm going to stick it right here, let's say, or let's, oops, that's not my, wait a second, I want to make sure I'm on the right one. Got to select that before I select this. There we go. And one more final thing is I want to make sure that my cumulative percentage and my chart output is both selected. Now, when I click on OK, the computer will automatically create the bin, the frequency analysis, and you can see here the numbers are the same. My frequency is here. It shows you the breakdown of also a cumulative percentage, so I could have done a percentage on top of that, but this tool does that for me as well. And you can see it doesn't show you the formula, it just does the calculation as a static and performs the information. If you wanted to change this data, let's say the data was wrong, let's say this person actually missed only 2 days, this data doesn't change. So that's a problem. You'd have to go back up into the data analysis, select the histogram, and redo it. And it would do a subtle change. You can see here it modified it just very, very slightly because I made a change to this. So keep that in mind that it's not dynamic. It is just, it's static is what it is. And it also brings up a histogram. Oh, and I did this twice. That's probably why there's 2 of those. Yeah, because I remember I ran it twice. And that's producing the histogram right here. All right, let's do another one here on correlation. All right, I just checking out the correlation, and what I want to do is I want to find a correlation between the this one here, the scores, and the absentee. Again, like we talked about before with the function called correlation, but this time let's use the data analysis tool for correlation. All right, now to do that, I'm going to go back into my data tab, click on my data analysis, and I'm going to pick a tool here called the correlation. And the correlation in this example here is I want to have my input range. My input range is correlating my SAT scores with the number of days the student was absent, similar to what we did before. These are grouped together in columns, that's important, and also label in the first row. At the top, I've included the labels. That helps in the output. The outputting where I want it, I'm going to say I want it in F12 right here. And I'm done. So I click on OK. And it comes up and it tells me that the SAT scores based on absentees is calculated at negative 0.953922, which whatever that means. Is there a correlation? Is there a correlation between coming to class and getting a high SAT score? You can see here someone missed 10 classes and they got a very low score. In this example here, they only missed 2, but they got a very high score. So if you looked at all the absentees, you probably see that there is a logical correlation. We could do this in another way by looking at the data, click on filter. Let's just sort according to the smallest to the largest. So for example, this person never missed a day and they got 2,200. And you can see down here, as we miss more days and more days, the numbers become smaller and smaller. So there seems to be a very direct correlation between these two data sets. And I believe as long as the closer it gets to 1 or 0, there's more of a direct correlation. And if I was to graph this, I'm not sure if graphing it would really give a better visual of how that looks. Let's just have a chart. No, I don't think that's going to give you really a clear representation of it. No, I don't think that's going to work at all in this case. But we could do even more analysis, like what is the average score of everybody who got 0? All right, so the average score here is 2211 compared to people who missed 10 days. The average score is only 573. So you can see there's a definite correlation between the two. So that's showing another tool here called correlation, using the data analysis tool pack. And covariance is another one, and you could go through and do multiple ones. I don't have time. Ranking and percentile, looked at this a little bit using the functions, but this analysis tool pack also has their way of doing a ranking and percentile. If you're doing a lot of this, you'd probably be using this tool a lot more. I don't use this tool very often, except when I want to take student grades and I do a bell curve, I do a histogram, just to see if my class averages are close. I do this when I do student mark analysis. All right, so in conclusion, we've pretty much gone through the majority of Chapter 8, and of course I go through these rather quickly compared to going through it in the class, but you guys can always rewind or watch it again. And I do encourage you to open up the book, and you can go through, and a lot of this, what I talked about here, is been repeated in my video. Of course, I'm just using this as an example. As you can see here, we've covered most of this in this lecture today. So I think that's it for today. I will see you guys in the next video.